Good day everyone! Welcome to Project M Squared. I am Sir JC, your guide in making math easy. This video is guided by the most essential learning competency of solves word problems involving permutation and combination. Are you now ready? Let's now start solving word problems. Number 1. In how many ways can the letters in the word nurse be arranged if the first and the last letter must be vowels? You can pause this video enabled for you to answer this at your own pace. We know that there are 5 letters in the word nurse, and each character is distinct. No letters are used more than once. Given the condition that the first and last letter must be vowel, it is easier to represent the scenario using fundamental counting principle. Given that there are only 2 vowels and 3 consonants in the word, we can identify a total number of arrangements satisfying the given condition. Since we only have 2 vowels, we have 2 possible outcomes for the first letter. It is either the letter U or E. Suppose the first letter is chosen as U. That will leave us one possible outcome for the last letter, which is the vowel, and that is letter E. So the first and last letter is now chosen. The second letter has 3 possible outcomes. Those are N, R, and S. Suppose we have chosen N as the second letter, we only have 2 possible outcomes for the third letter. That is R or S. By choosing R as the third letter, we only now have one possible outcome for the fourth letter, and that is S. By fundamental counting principle, we multiply the total outcomes for each event to happen. 2 times 3 is 6, times 2 is 12, times 1 is 12, times 1 is 12. Therefore, there are a total of 12 arrangements wherein the first letter and the last letter are vowels. And one of those 12 arrangements is the arrangement of U, N, R, S, E. Let's now move on to the next problem. In how many ways can 4 identical green beads and 4 beads of varying colors be arranged on a string? Again, you can pause this video enabled for you to answer these at your own pace. Let's now have the answer. In this given problem, we only want to find the number of distinguishable permutation given that there are 4 identical green beads to be arranged together with 4 varying colors. Since the 2 ends of the strings are not to be connected, it is just like arranging objects in a row. In all, there are 8 beads to be arranged in a string, in which 4 of them are identical green beads. Using the formula for distinguishable permutations, the number of permutation P is equal to n factorial divided by r sub 1 factorial multiplied by r sub 2 factorial multiplied until r sub k factorial. where r sub 1, r sub 2, r sub k represents the number of identical elements found in N. By substitution, since the number of beads is equal to 8, we let N is equal to 8. And there are 4 identical green beads, r sub 1 is equal to 4. By substitution, N is equal to 8, that becomes 8 factorial divided by 4 factorial. By further evaluation, 8 factorial is the same as 8 multiplied by 7 multiplied by 6 multiplied by 5 multiplied by 4 factorial. And this is divided by 4 factorial. And 4 factorial will be cancelled out. So we find the product of 8, 7, 6, 5. And that is 1,680. Therefore, there are 1,680 distinguishable permutations for 8 beads to be arranged in a string wherein 4 are identical green beads. Did you get all the answers correctly? If so, great job! I hope you learned something from this video. Again, this is Sir JC reminding you, math is easy when you perceive it positively.